Welcome to video lecture on image processing laboratory programs. So in this video, you will understand how to write a program to detect face or faces in an image. Let us start with importing necessary libraries. We need to import CV2 here. So import CV2. Then afterwards, these lines loads a pre-trained HAR cascade classifiers for face as well as eyes. So we need to detect both face and eyes in the program. So for that reason we are going to load pre-trained classifiers. This HAR cascade classifier are machine learning algorithm used for object detection methods and to identify the objects in the image. The classifiers are stored in the XML files provided by OpenCV. So that can be fetched with the help of data.har cascades. This is going to help me to fetch the points, or it is going to point the directory where your XML files are located. So after fetching the locations of both face and eyes with the help of these two pre-trained models, the next step is to read the input image. So read the input image as usual procedure with IAMRead function. Then you all know that we need to convert your RGB into grayscale image. So convert using this function, because all the algorithms which are more suitable for grayscale image rather than RGB, so we are converting it. After this, we need to detect the faces in the image. For that reason, so what we are doing is dot detect multiscale function is being used for detecting the faces. So now one by one each parameter will understand what is it. The grayscale image which is been converted here, passed as a input image to this function. After that we are setting the scale factor to 1.3 here, and this is used to resize the input image for different scales. Why? What is the necessity of doing this scale factor is, the reason behind this is faces can appear at the different sizes. If you just notice that in any photographs, if any face which is near to the object near to the camera, which is larger, which looks larger in the image, and the smaller objects, they are very far from the camera. So for that reason, to detect faces of different sizes in the image, the algorithm needs to inspect the image at different or multiple scales. So you have to give the parameter like this, okay, and scale factor to be given. And also, not only this reason, there is one more reason to make use of this is by reducing the size using the scale factor, the algorithm can scan the entire image faster and more efficient. So these are the two reasons to use the scale factor. And we have set the value called 1.3. Let us understand why this 1.3 here. It actually balances between the accuracy of the algorithm and speed of the algorithm. So higher the value that you give it over here, which is going to reduce the accuracy, say for example 1.3 and above, if I give, it's going to reduce the accuracy of the algorithm, so you don't use that. Similarly, 1.1 is the lower value, either 1.1 or lesser than this. If you give lower this value, it is going to affect the speed of the algorithm. That means algorithm takes much time in order to execute the process. So ideal value that people have found is 1.3, and you can vary this to 1.2, 1.3, 1.4 and see the results in your output. And followed by, there is one more parameter called min neighbors is equal to 5. So what is the role of this min neighbor parameter is, which helps to ensure that the detected faces are reliable or not, okay, or whether they have randomly patterns were identified by the algorithm. Any false identification is done. For that reason we give the value. Higher the value which you are giving here is going to give you fewer detections in the output, but which will give you higher quality. So lower the value, it's going to give more detections that might give you false detection in the output also. So by varying this value also you can check how the algorithm is working for your input image. Now after doing all this, you need to draw the rectangle, because we have detected all the faces in the image. Once the detection is over, we need to draw the rectangles around the detected faces. For that reason we use the loop iteration over the list of detected faces. For each face, it draws a rectangle around the detected faces in the original colored image. So for that reason I have to pass the image as the parameter to this dot rectangle function. Then xy, that is in say for example this is the detected face, I need to give top left corner value of the rectangle, so that is xy. Then height and width to be provided in order to obtain bottom right corner of the rectangle, so that you can plot this rectangle. So third parameter is x plus w and y plus h. After doing this, you need to have a color, in which color you want to plot, and the thickness, and you know the color values to give. Here it's not RGB, it is BGR, because most of the cameras give less priority for the R value, so that's why it's been considered at the end. So BGR is most of the cameras that they were using earlier, so that's why we are maintaining the same thing here, BGR. So blue color I want to plot it, so I have given 255 for that. Then thickness is 2, which is being considered. Once all this done, you have to just write your rectangle. After finding out the rectangle, draw the rectangle, you need to show that output how it looks. I am write all the detected faces, label it on the image. Then I am show function to be used to display the image. This is not required actually. With this itself you will be able to obtain the result, and your file is been created with the name called detected faces. And as usual, finally wait key can be used or not. Even without this it will work, and destroy all the windows. Hope you understood the concept. This is what output which we are going to get after executing the program. This was the image which I had given without the rectangular box, and face is detected. You can also check with the different images where more than one faces are there, and see the result, how it's going to give. I hope you understood this. Okay, finally I just wanted to give additional information on Haar face detection algorithm. So this algorithm detects faces by first creating a Haar cascade classifier, and that classifier is being trained with a positive samples and the negative samples. The meaning of positive samples is your samples should have images or faces in the image. Negative samples are the one which are not having faces in it. So by giving both of them, this classifier has been trained already, and that classifier was used in our program. So let us move on to other face detection algorithms which are available, like your Haar cascade face detection. We also have eigen faces, Fisher faces, CNN model, YOLO face. Like this, many more algorithms are there. You can explore them personally. Then apart from this algorithms, we also have open source face detection models which are already available in the market, like MTCNN. So what is MTCNN stands for is multitask cascade convolution neural network, and Blaze face. Then DLIP is another one. OpenCV hard cascade classifier is what we have used, and FaceNet, like this many more which are available in the market. Now we will understand why this hard cascade that we have used here. It can detect multiple objects within a single frame in a hierarchical manner. So for example, detect face, eyes and humans in the image. So that's why we have used this algorithm. And actually HCC or cascade classifier is a feature based object detection algorithm to detect the objects from the image. This algorithm does not require extensive computations, and hence this can be used in the real time applications. So here R cascade uses R features actually in order to perform the task in the algorithm, and to determine the likelihood of a certain point being a part of the object. So you need to understand what is likelihood for more clarity. So likelihood, you already know that it refers to the degree of belief or expectation that something will happen, right? Whereas probability refers to the ratio of all favorable outcomes to a total number of possible outcomes. If I have to present them in a graph representation, I just wanted to show a normal distribution. Okay, here this is the mean and standard deviation. Let us understand what is probability and likelihood. So the probability is actually, as per the definition, it refers to the ratio of the favorable outcomes. Say for example, these are the favorable outcomes that I have to find out, all the objects which appear here. So this divided by total, all this will give me a probability in terms of percentage. Okay, so whereas likelihood is knowing the evidence and or else knowing the known value, finding an unknown object or unknown parameter. So for example, I want to find out the likelihood of this point. This is known point, x-axis. Finding out its corresponding y-axis point. So this is what my likelihood. Okay, I hope you understood the difference between likelihood and probability. So because of this reason, this is one of the important algorithm which has been used for detecting the objects. Okay, I hope you understood all the concepts of related to 12th program, which is R cascade face detection algorithm. Okay, thank you.